Okay, we're going to take a look at differentiability. If a function is differentiable, that means you can take the derivative. So if a function is going to be differentiable, or if you can take a derivative, it has to be continuous and smooth. We have a pretty good idea of continuity, but smooth refers to the slope of the graph. A function is smooth at a point if the slope changes gradually. If the slope makes an abrupt change, then it is not smooth. So we would see that with a corner or a cusp. The derivative also fails to exist at a vertical tangent because the slope would be undefined, or a discontinuity, it would not be continuous. Most of the functions we're going to be looking at in this class throughout the rest of the year will be differentiable, but it's important for us to understand this concept that not every function has a derivative, at least at certain points. So we can take derivatives using the calculator. Okay, so we can take the derivative of x cubed on our calculator. And you should get 3x squared. And if we want to take that one step further and find the derivative of x cubed when x is equal to 2, we've got a couple options here. We can find the derivative at a point using these steps. And just to point out, there's actually another way we could do this, which some of you might prefer, which would be to hit Control equals after you've typed in derivative of x cubed and use the vertical bar for such that, and evaluate the derivative of x cubed such that x equals 2. It would perform the exact same thing. Okay, and just a warning, as always, that you need to be cautious when you're using a calculator to be aware of what you're telling the calculator to do. If you take the derivative of 1 over x when x equals 0, well, that's undefined because there is no value when x equals 0. So the calculator returns negative infinity, but we need to know that that's not true. If you take the derivative of the absolute value when x equals 0, we know that that's a corner, so the derivative is undefined, but the calculator returns plus or minus 1 because it's looking at the slope coming from the left and coming from the right. But we need to understand that really the derivative is undefined at that point. So if we graph natural log of x, we can graph the derivative of natural log of x. And you can actually, in the graphing line, you can type in derivative of natural log of x. This is just another way to find the derivative. And you can see it gives us this graph right here. This looks like 1 over x. And we could use the calculator to evaluate the derivative of natural log of x, and it'll return 1 over x. But we need to be aware that natural log of x is only defined for values of x greater than 0, so it doesn't make sense to have that left side of the 1 over x graph. So even though the calculator tells us the answer is 1 over x, it's really 1 over x for values of x greater than 0, only the right side of the graph. Okay, so a couple theorems to look at here. If a function has a derivative at a point, then the function is continuous at that point, which makes sense because if a function is going to have a derivative, it must be continuous. We often use the phrase differentiability implies continuity. The intermediate value theorem for derivatives. Here's another one of those, one of our few theorems that we really need to have memorized. So if a and b are 2 points in an interval, and that function f is differentiable, then f prime takes on every value between f prime of a and f prime of b. So we're thinking of slopes here. At this f prime of a, we have a slope of 1/2. At f prime of b, we have a slope of 3. The function is differentiable, so the derivative takes on every value between 1/2 and 3. Or in other words, the slope takes on every value between 1/2 and 3 between those 2 points.